Okay, let's say we have a skier.
We have a skier.
Thank you for saying we have a skier. And we have a 30-degree slope. And we have, oh, I'm going to draw a skier.
You got this. Oh, that's beautiful.
There we go. Okay, so we have a skier. And
a giant skier compared to the mountain.
Well, it's only a section of it.
Yeah.
Hopefully.
Okay, and so this skier, we're going to say, is going down the mountain at a constant speed. We had a problem with the skier earlier, but now the snow has become a little more slushy. So we've become frictionier. So we have more friction. And so I'm wondering now about mu k. So we're going down the slope at a constant speed. So let's draw our free body diagram. And y'all tell me what to do on my free body diagram.
Gravity straight down.
Gravity straight down.
Normal force perpendicular to the plane.
Normal force perpendicular to the plane.
Or as close to perpendicular as we can.
Well, yeah, we'll pretend that that's perpendicular.
Friction heading up left.
And friction heading, I didn't mean to change the color already, but there we go. Friction that way. Okay, lovely free body diagram. We have put all the forces that are acting on this, but I am not satisfied.
Because we have to resolve the vector.
Yeah, we've got to resolve the vector. We need everything to be in perpendicular components. What is a useful, just force of habit to do when you've got an inclined plane? How do you go about resolving your vectors?
Turn the paper.
You can turn the paper and look at it that way.
Draw that line down, and then whenever it would make a 90-degree angle with the vector for that, you just go down, and then you have a triangle.
And then I have a triangle. So I draw my vector down. Whenever it'd make a 90-degree angle, there I've got my triangle. And then, do I know anything about my angles?
30 degrees.
Yeah, my bottom angle will be 30 degrees if I drew it correctly. And then this side will be mg cosine 30. And this side will be mg sine 30. By the way, if you think about it, and if you think about doing some laboratory problems, the effect of putting something on an inclined plane is basically sort of to dilute, if you want to think about it that way, dilute gravity. Because your force down the plane is going to be the force of gravity times the sine of some number, and the sine of some number is going to be less than 1. And so you can do inclined plane problems, and you can see that your acceleration down your inclined plane is going to be a fraction of gravity. Okay, so let's see. Can we say that we know what the normal force is? And what is that normal force?
It's going to be equal to mg cosine 30.
Yeah, mg cosine 30, because we only have two forces perpendicular to the plane. We have the normal force, and we also have the component of gravity that's perpendicular. We have no acceleration perpendicular to our plane. Our skier is going straight down, and so the normal force has to be mg cosine 30. Okay, how about parallel to the plane? What forces do I have?
You have
Friction going back.
sine of 30.
So I'll say my net force, called down positive?
Yes.
Yes.
Okay, mg sine 30 minus my force of friction, or my mass times my acceleration, will equal mg sine 30 minus mu k times the normal force, or ma equals mg sine 30 minus mu k, which we don't know in this problem, times mg cosine 30. Well, now we're happy because we didn't have the mass. We were hoping they would cancel, and sure enough, they do cancel. What do we know about our acceleration? Do y'all remember how I set this problem up? You had 0 moving at a constant speed. So 0 equals g sine 30 minus mu k cosine 30. Now we're going to use a little trick here. No. Oh, I thought I was looking for an angle. I'm not. I don't need to use any trick. I'm looking for the coefficient of friction. I was all excited to use a little math trick. Oh well. Okay, sometimes, okay, speaking of math trick, let's say you had to find an angle and you have a sine of theta and a cosine of theta and you're like, oh, how do I solve this?
You put one to the other side and square both.
No. You take one and you put it on this side and then you divide both sides by cosine of theta and then you end up with just tangent theta. So like if my unknown were theta instead of mu k, I would add mu k cosine theta to this side, divide both sides by cosine theta, and then I would get tangent theta.
You could still do that and then you would isolate the mu k.
You want me to take this to this side and square it?
No, and then divide by the cosine 30 and then you just have your mu k, which you're solving for.
Oh, yeah, I could in this one, but I don't need to. So, okay, so what I'm going to do is just solve for mu k. So, I don't feel like solving for mu k. Can someone tell me what mu k is?
1 second. What, right? No. 1 sec.
No, it can't be 5 point something. It's kinetic friction. It's got to be less than 1.
Yes.
Oh, this shouldn't be too hard.
It shouldn't be.
Okay, well if you put mu k cosine 30 to the other side and then divide both
UK
sides by
cosine 30 equals 9.8 sine 30 UK. Yeah, alright, so we are ending up doing that anyway. Tangent 30 equals...
This doesn't work.
Yeah, I don't know what's happening. Like
Would you like to look at this?
No, I believe you, so let's see, what am I doing wrong? Did I... Oh! Let's see, did I end up with a problem that can't work? That's
Yes.
possible.
Yes.
I probably ended up...
You need to reduce the angle by a lot.
So I must have ended up... no, let's see. I think I'm missing... Why do I have...
It works if you reduce the angle by.
I forgot I have an extra... I forgot a G.
Forgot a G.
Forgot a G.
Oh, okay.
G's cancel. So I end up with just tangent of 30.
Okay, that's... Which is...
0.577.
0.59.
0.59. Coefficient of friction, does it have any units?
What did you do?
Oh, 8, sorry, not 9.
Oh, 8,
Okay,
not
It's
9.
a horrible, horrible mistake.
Yeah. So coefficient of friction, does it have any units?
No, it's a coefficient.
Yeah, it doesn't have any units, and if we think about it, we can see why. Because we're saying
that would mess up
that the
equation.
coefficient of friction equals mu k times the normal force. This is a force, so we can't have any units on this one.